Hello everyone and welcome back to another video in our Autodesk Inventor professional tutorial. In the previous videos we talked about the mate and flush constraints, and in the last video we did a quick exercise assembly which was a palette assembly, and we used the mate and flush constraints to build those relationships between the components. In this video, we're going to talk about the angle constraints. Angle constraints are very similar to mate and flush constraints, but it just gives you more control. And as we go into it, as we talk about the details of angle constraints, you will have a better understanding about what kind of control angle constraints give you. So we're going to create two simple components, actually three simple components, and we're going to add these relationships, add these constraints between these components, and that's going to help us to explain the angle constraints better. So let's start our first component, go to the drop-down menu, select Part, and that will take us to the Part mode. And Autodesk Inventor will just name it as Part 1, which is fine. And we can start a 2D sketch and select XY plane, go to the rectangle, select 2-point center rectangle, go to the origin point and start drawing a rectangle in the sketch mode. Let's say this is 100 millimeters and this is 1000 millimeters, so 100 by 1000. And let's zoom out and finish 2D sketch and extrude that. And let's say this is 50 millimeters of an extrusion. It's a simple 3D object, right? There's nothing tricky about it. And let's say we want to also add a hole here, because we're going to use that hole to build more relationships between the components. So before we draw a circle, actually, let's project the geometry so we can take advantage of the edges of the 3D object. And we can draw a center circle here, center point circle. This is in this purplish color because it's not fully defined. So let's add some dimensions. Let's say this is, say, 100 millimeters away from the bottom edge, and add another dimension. This was 100 millimeters, so 50 millimeters. We'll make sure that the center point is in the middle. And also it will need a diameter, right? Let's select the circle and add a diameter. Let's say it is 40 millimeters. So these are the dimensions that I added, and let's finish the 2D sketch and extrude that. We don't want to add material, we want to take material out. So let's just switch to cut and say through all, so it removes all the material on its path. So let's hit OK. So this is our first part. Now let's save this part. I created this folder named Angle Constraints on my desktop. You can do the same thing, or you can just save the parts on your desktop. This is just an exercise part, so it doesn't really matter. I'm going to leave it as part 1, so let's just save it that way. Now we need a second part. Again, go to the drop-down menu and select Part, and that will take us to the part mode for part 2. Now again, do the same thing for the second part. Let's again draw another rectangle. This time, let's call it 100 by 800. So it's slightly different. That way, it's going to be easier to separate two components. So finish 2D sketch, extrude, and again, apply 50 millimeters here, and new sketch, go to the bottom and do the same hole here. Again, project geometry, add the circle, this was, what did I do? 100 millimeters away from the bottom edge. It's right in the middle. This is total of 100 millimeters. If for some reason, if you can't remember, you can always right click and you can find measure here, and you can just simply select these two edges, and you can see that this is a 100 millimeter distance. And the measure window will also give you that information. And you can, of course, come here and enter 50 here, and that will make sure that the center point of the circle will be in the middle, coming from the origin point. And now the only dimension that it needs is the diameter. I believe we said it was 40, right? Yes, 40 millimeters. So finish 2D sketch, and then extrude, do the same thing. Do not add material, but remove material through all. Okay. Now we have two parts. Let's save this too in the same folder as part2.ipt. So now we created two very similar components, right? The first one is part 1, and it's got a hole about in the same area, right? Part 1 and part 2. So now let's create a third component that will fit in this hole that we added to these 3D objects. So let's go to part again and start 2D sketch, and on the XY plane. And this time, let's draw a circle. And this is going to be 40 millimeters in diameter. And finish 2D sketch and extrude that. The thickness, the extrusion was 50 millimeters for the first part and 50 millimeters for the second part. So this is going to be 100 millimeters in length, in height. Yeah. And let's save that too. And this is our part 3. So we have these 3 parts, these 3 components that we can add to the assembly, and we can add relationships between these components, and we can uh, explore more about the angle constraints and other constraints again, just as a practice. Again, go to the drop-down menu, select Assembly. Um, in the previous video, I believe we did Control-C, Control-V, and then we started like holding the component here and dropping in the assembly. We did that. Again, in this video, let's use the Place Component feature. Now, since this is the folder I used last time, so it automatically went to that last used folder, which is the angle constraint. So for some reason, if you're not seeing the folder you're working with, if it takes you to downloads or documents folder or desktop, just basically uh, find a folder you want to use. In this case, it is the angle constraint. And I will select part 1 and hit OK. It will bring it to my cursor in this transparent view. It's expecting me to drop it on the screen, and I can continue to add more, but I need one of each, so I'm not going to do that. I will right click and hit OK. And then let's add the second component, and I can actually hold down the control key and select part 2 and part 3 together. Click OK, open and add the components right here, and right click OK. Notice that when I added the components like this into the assembly, it did not ground any one of these components. So let's just select one component and check grounded in the right click menu. So let's say this is our grounded component, and right click and select grounded. Notice that that thumbtack icon appeared next to the part. So now let's start applying constraints to create these relationships between these components. So what I want to do is, let's move this aside a little bit. I want this part and this part to be mated. So I go to constraint in the right click menu. I'm looking at the type. I'm in the mate, and the solution is the mate solution. So I will select this surface, and I can already see the preview of the constraint I'm going to use. So it's looking at this way. You can see the green arrow. And then I will come to this component and select this surface. Now they will be mated from those surfaces, and you can see that 2 arrows are looking at the opposite direction. Now let's hit apply, and I want these to be flush here and here. And then again, I change the solution to flush, and then go back, and I want these to be flushed at the bottom surface. Now the hole should line up, right? Because everything is in the same location for both components. The hole is in the, we use the same dimensions, same values. And I didn't have to do that. I could have, I could have, instead of adding flush constraints, I could have taken advantage of the hole as well to apply a constraint there. I could have done that, use the axis of the cylinder. Actually, before we talk about that, I want to point out that there is a relationships folder here in the assembly, and you can expand that and see all the constraints you added. I added a mate constraint here, I added a flush constraint, I added another flush constraint here. Notice that if I click on it, it gives me a text box here where I can enter offset values, and we're going to talk about that as well. And these relationships are listed here, but also you can see them under the respective components. So this mate 1 is applied to part 1 and part 2, so you can find it under part 1 and part 2. So you should not be able to find it under part 3 because it is not applied to that component. So now, where is our pin? It's right here. I was going to show how to apply the constraint using a cylindrical part and taking advantage of the hole that is available on the component. So let's do that. Let's delete these 2 mates that we added, 2 constraints that we added. That way this part is again moving. The only constraint I left is the mate constraint on these surfaces. So let's right click, go to constraint. While leaving the solution as the mate constraint, I can go here and find this hole. And as I hover on this, not the edge, not the point, but if I come to the kind of like an internal surface of this hole, you will see that the axis of the cylinder is cylindrical shape is going to appear. So I can select that, and I come here. I can do the same thing for the other hole, and that will line up these holes. And let's hit apply. Now everything is constrained, but now it's still asking for one more constraint. Now I can add one of the flush constraints that I deleted. So I can make these surfaces flush, and I can come down and I can make these surfaces flush, and that will make sure that this uh, component that's currently moving this way would not move because it would be fully constrained with in reference to the um, grounded component. So now let's just leave it like this. I'm happy with this orientation. I'm not going to add more constraints here. Now I want to add the third component. I want to add constraints for the third component, which is the pin. So let's right click and go to constraint. And then as I come to this pin, again, the same axes will appear. And if I actually keep my mouse there long enough, you can see that axis is highlighted here. And now you can come down to this drop-down menu. You can select the face of the cylinder. But in this case, what we are interested in is the axis because we're going to insert this into the 40 millimeter diameter hole that we added to the 3D object. So let's select the axis here. And again, come here and then select the axis of this hole here. And now the pin is inserted there using this solution. And again, notice that solution type changed as I use this type of constraint. It's not surface to surface, it is the axis to axis. So it is Autodesk Inventor is automatically adjusting itself to provide you potential solutions that you might want to use. So let's hit apply because we want this window to be available to us because this is not complete. It's sticking out a little bit. So let's go back to the flush constraint, select this surface and select this surface. That way the end surface of the pin and end surface of this 3D object are flush. So let's hit apply. Yeah, so I have this pin, I have this shorter 3D object, and I have this longer 3D object. So just to make it look easy to separate, let's assign some appearances to it. I know we didn't do this in the past, but it's pretty straightforward, and we're going to go into it in more detail in the future videos. But let's click on this adjust button here, and as this part 1 is highlighted, let's maybe assign an orange color to this and hit OK. And then click on this second item, which is part 2, and go to the adjust button here on the top, and let's maybe assign a greenish number here. And you can see the RGB values here as well, and you can hit OK. And then we have this third component. Let's make that maybe like a purple. Yeah. Yeah, so now we have orange, green, and purple components here making the assembly. And now which one is our grounded component, which is this orange one. So now notice that this green component is rotating around that pin, and that pin is fixed in a position on the part 1, which is the orange component. So now I can maybe experiment with the angle constraint. So let's right click and go to constraint menu again. Now instead of using the mate constraint, I'm going to switch to angle constraint. Notice that a bunch of things changed here. Now you're not entering a dimension, you're entering an angle. You're entering how much, 10 degrees, 20 degrees, 30 degrees angle. And then your solution types changed. And your selections, now you're selecting maybe potentially 3 selections. This first one is directed angle. This directed angle is kind of, was really popular in the older versions of Autodesk Inventor. Currently, it's not, I do not recommend you to use it because when you use directed angle, your limits are grayed out. So in your case, place constraint window might look like this, and you can just click on this button here and expand that, and you can see that the limits are grayed out. You can't use it. But just to show you what it does, and basically you select this surface and select this surface. Since we did not enter any value, the default value was 0 degrees, it basically made them flush. So this is what I meant by, just angle constraint is very similar to flush constraint. It just did the same thing for us. But now we have more control. Now we can just apply 0 degrees and accomplish the same thing with the flush constraint. Or I can change this to 10 degrees and I can already see it change on the screen. So I can maybe reduce it to 3 degrees. I'm not going to apply, let's apply this actually. So now this angle constraint is applied. And notice that in the relationship, you can see it under the part. You can see it under the part 2 here. Angle is applied. You can see the 3 degrees in parentheses as well. And also you can see it in the relationships folder. It's right here. And you can see the preview of the angle constraint you added. So when you click on this, a lot of people try to delete this by hitting the delete button on their keyboards, and they accidentally delete this 3 degrees. So just to get away from that, just right click and hit delete. That way you can delete that constraint, and this goes back to moving left and right. I wanted to show you something here. When you right click and hit constraint and go to angle constraint, and for the directed angle, notice that in the first time I did, I selected this surface first and then this surface first, so I entered 3 degrees. Let's select this surface first and then this surface first and enter 3 degrees. What's different this time? See, the green component actually went backwards. When I selected the orange one first and then the green one, green component kind of went left side 3 degrees. Notice that I did not enter plus or minus in front of the angle value that I entered here. So I just accomplished the same thing by changing the sequence of the selection. But as I mentioned a few minutes ago, this is kind of a legacy option. What I recommend to use is undirected angle. So let's just cancel out of this and then go back and let's just leave it right here and go back to constraints again, go to angle constraints, select undirected angle, and now the limits are available. So let's select this surface. This surface is just the same way we did with the directed angle. Now let's enter 45 degrees. So it's going to be 45-degree constraint applied to it. So I'm going to go back to 0 here. So it goes back to flush. I'm going to use this angle as the resting position, meaning that this is the default position. And I'm going to just put a check mark on that option under limits. For maximum, I'm going to enter 45. So it goes 45 degrees maximum. For minimum, I'm going to leave it at 0 and hit apply. Now what I did is notice that there's plus and minus symbol next to angle, which means that it's got a maximum and minimum angle value. But it starts from 0, which is the resting position. Now notice what happens here. I can come here and drag this component all the way to 45 degrees and no further. And if I can just let it go, it goes back to its resting default position, which is 0 degrees, which is the flush position. That's why when you go to, well, let's just right click on this and hit edit. And that's why this option, undirected angle, is now more commonly used. We will look at this other option in the future. It's not very commonly used, but we will look into it later. I want you to do more practice with this undirected angle and maybe play with the maximum and minimum values. But even if you don't do it at home, we will do more exercises in the future videos, and you will see me using this constraint type between several components to uh, create these relationships in the assembly and put them in the orientation we want them to. Well, until then, uh, just try to if you feel like there's some things that I mentioned that we covered in the previous videos, feel free to go back to those videos. But we will continue to talk about the constraints in the following videos. And thanks for watching. See you in the next videos. Bye bye.